Muhire Jacob presenting in the D3 assignment. These are my details. That's my registration number and student number. I'll be showing the actual uh, graphs, visualizations after the slides. These are the contents. We have an introduction, the scatter plot, do the bubble plot, stack bar graph, do the map visualization, and the data table. Introduction, we used the D3 library, and the methodology we used was involved doing some data transformation on the data set that was provided, and cleaning it, particularly with the longitude and latitude values. The other features we did not make any changes. And the presentation is on 5 visuals, which have been mentioned earlier as listed. We have a scatter plot where we looked at 3 districts, Jinja, Bujiri, and Iganga. And it was here, and I looked at mainly 2 variables, which was the pH and sulfates. What I also see is that this scatter plot is a positive trajectory, where you can see Jinja's values were in purple, Bujiri's were in green, and Iganga were in yellow. So you get to see that Iganga has very high pH and sulfate values, followed by Bujiri, and then Jinja followed lastly. What we also see is this is a bubble plot, and what we also get to see, it was for pH for all the districts, and we also get to see that in their descending order, we get to see that the districts with the highest pH were Kamwenge and Lamo, followed by Luka. Then we had Bujiri and then Jinja. Following closely, those are the districts that had the highest concentration. Looking at the bubble plot. So for our stack bar graph, we're looking at all the districts, and the chemical components we're looking at were total alkalinity, total hardness, and calcium hardness, which was stacked. Calcium hardness was represented by green, total hardness was represented by yellow, total alkalinity was represented by blue. And what we get to see here is that Lamor has a very high values of all these 3 features, and then followed by Ujiri and also Anjija. But this can also be attributed to these districts having the largest number of data collected in comparison to the other districts. This is our map, which shows locations of the water points. This map has zooming and panning features, as we shall see with the live graph. And lastly, we have the data table. In this data table, we have 3 filtering functions. We have searching by text. You can filter by district, and also you can filter the number of rows you want to view. This helps with reviewing the data that is in the data set. So with that, I would like to thank you and move over to the actual live system in the browser. So we get to see this is the system. These are the dashboards. We get to see the scatter plot. It's the first visual on the top left. Then we have the bubble plot on the right. And down here we have the total alkalinity, which shows Lamo here having the highest number of records, or highest number of recorded values with the high calcium hardness recorded, followed by total hardness of the water, and also total alkalinity, which is also the same in this case here with the bubble plot. So we have our map here, which shows the geolocations of the water points, with the highest number being in eastern Uganda, and others are scattered all over the country. We have some in the north, but majority are in the central east and central region. We can zoom in and zoom out of this map to view at different levels of detail. And then when we come down here, we have our data table, to which it is dynamic, so we can actually filter. We can filter out what we need to look at. As you can see, I'm typing Buwenge and Buwenge in Jinja, and it reduces the values. And we can as well filter the number of records. Once you 50, we can see the 50. Once you 20, we can reduce it to 20 or reduce it to 10. And this is all done in D3, reading the CSV. And with that, I would like to end my presentation on the water quality dashboard. Thank you very much.